Recall that a statement that is always true is called a tautology, and if an argument in the form as, for example, a syllogism is a tautology, then it is a valid argument. In section 3.7.3, we will examine the pattern of incorrect reasoning or fallacies. Definition: an argument that has incorrect reasoning is invalid. An invalid argument is also called a fallacy. Let's look at an example. Determine if the following argument is valid. If Gray lives in Amarillo, then he is a Texan. Gray is a Texan, therefore he lives in Amarillo. Sounds pretty good, right? Unless we really listen critically. Let's analyze this argument by converting it to symbolic form and testing its truth value with a truth table. The first thing we need to do anytime we're analyzing an argument is to identify the simple statements that it is composed of. Remember, simple statements do not contain connectives. So I'm going to leave out the connectives and identify our first simple statement. Gray lives in Amarillo. Then as a connective, he is a Texan. So that is another simple statement. You can say Gray is a Texan, or you can say he is a Texan. Gray is the only person that we're talking about here, so we'll know he refers to Gray. Next statement, Gray is a Texan. Well, that's statement Q. We've already identified that. Remember, we had Gray lives in Amarillo and Gray is a Texan. Therefore, here comes our conclusion. He lives in Amarillo. Well, that's a repeat of statement P. So it looks like our argument is only composed of two simple statements. That's good news. That means our truth table will be short with 4 rows only. Next, we're going to break apart this syllogism into major and minor premises and the conclusion. The major premise is simply the first statement in the argument. If Gray lives in Amarillo, then he is a Texan. The minor premise is the second statement in the argument. Gray is a Texan. And our conclusion, C, therefore, you can use the symbol if you want to. Therefore, he lives in Amarillo. Now, we're going to take our simple statements and use those to write each part of our syllogism in symbolic form. So let's start with our major premise. Our major premise is a conditional, if, then. So we've got a one-way arrow. Gray lives in Amarillo is statement P. That's the hypothesis of this conditional. And the conclusion, he is a Texan. So our major premise is a conditional. Our minor premise says Gray is a Texan. Well, that's a very simple restatement of Q. And finally, therefore, he lives in Amarillo. That is a restatement of our simple statement P. Now, we're going to express the entire syllogism, the entire argument, as one compound statement. And here's our pattern. We're going to take our first premise, which we discovered is if P, then Q. That's our first premise. We're going to join it together with our minor premise with the and symbol. Our minor premise was Q. And all together, that's the hypothesis of our conditional. I'm going to put that in brackets since we already have a set of parentheses there. Then we have our conclusion, C. Well, our conclusion we translated as statement P. So our entire English argument, our entire syllogism is now a one-line symbolic argument. So let's begin building our truth table. As I mentioned before, since we only have two simple statements, our truth table needs 4 rows. And we're going to set up initial truth values in the same way that we always do. In our truth table, the last column will contain our entire compound statement, our entire big conditional. So I'm going to squeeze that in over here. And then we're going to fill out our column headings based on breaking down this conditional. So this big conditional has a left side and a right side. Notice the right side is already accounted for over here. That's just a simple statement P. So that one's taken care of. Let's break down our conjunction. The conjunction has a statement on the left, if P then Q, and a statement on the right, Q. We will already have that truth value listed here. So the last thing that we need to do is join those two statements together in a conjunction. So if P, then Q, and Q. Now we're ready to fill out truth values. Remember, we need to know the rule for each conditional. We're only using one rule at a time, and we're only comparing a maximum of 2 columns at a time. So let's judge the truth value of the statement, if P, then Q. So the rule that we're using here is the conditional rule. And with that one, we're always watching for the one case that stands out. If true, then false, the conditional is false. Every other time it is true. I bet you're really getting used to that by now. In our next column, the rule that we're going to be using is the conjunction, or our and rule. So we're going to look at the left side of the and, that's this statement here, and the right side of the and, which is just Q. And it's okay if your columns are out of order for a conjunction. Remember, a conjunction is true when both components are true. So in row 1, both components are true. Our conjunction is true. In row 2, both components are false. Our conjunction is false. In row 3, both components are true. Our conjunction is true. And in row 4, you've got one of each, so our conjunction is false. Remember, 2 truths make a conjunction true. Okay, we're ready for our big conditional. In this last statement, we've got a left side. The hypothesis of the conditional is right here. And the right side of the conditional is P, way back here. Notice the order. We have to go from hypothesis to conclusion. So I'm going to go from this column to this column. And we watch for that one special case, if true, then false is false. So row 1, if true, then true, that's true. Next, if false, then true, that's true. If true, then false, there it is, that's false. If false, then false is true. Is the argument valid? Notice the argument is not a tautology. Not a tautology. It has one false. Therefore, the argument is invalid. Okay? So the reasoning in this argument is incorrect. Now, let me tell you something about Gray. Gray is my dad. Gray does live in Amarillo, and in fact, he is a Texan. So if I look at this conclusion C, Gray lives in Amarillo, well, it is a true conclusion. But when we're talking about the logic of this argument, this is an invalid argument. Think about where it might break down. Let's look at the case where it was false. It's going to be false when P is false and Q is true. So if P is false, Gray does not live in Amarillo, but he is a Texan. So if we inserted another name in there, a person may not live in Amarillo but still be a Texan, right? So we cannot conclude from the fact that they are a Texan that they automatically live in Amarillo. So make sure you know the difference between valid and invalid. That's correct reasoning versus incorrect reasoning, and true and false. I sincerely hope that you learned something from this chapter, that you feel a little bit more logical. And by that, I mean that you have the ability to kind of slow down and look at the details of an argument. The thing that I want you to understand here is the way statements are connected build the logic of that argument. Now, we've also learned how we can take an English argument and translate it into symbolic form. So you're beginning to learn how the English language is mathematics, and that mathematics is a language. In fact, grammar is simply a set of rules that identify patterns that we use to build language. Mathematics is a set of rules that we use to identify patterns and make conclusions. Now, one thing that the English language has that maybe mathematics does not is that within the English language, you have expression, you have emotion, you have artistry and creativity, and that is not expressed in symbolic logic. Symbolic logic is simply identifying the underlying structure, the rules, the pattern of the language, but symbolic logic falls short in the fact that it cannot express the color and beauty that our English language does express. But on the other hand, we might say that that color, that beauty, that creativity might not necessarily be there unless we had that underlying regular, predictable structure. It's almost like looking at a beautiful painting. If you look at a beautiful painting, there's pattern, there's repetition, there's symmetry, there's proportion. There's those hard and fast mathematical rules that govern the way a painting is put together, yet the painting is beautiful. It is expressive. It conveys emotion. So again, thanks for listening to my thoughts and ideas here. I hope you've learned something. And now that you've completed the chapter, and as soon as you finish up all your homework, you're welcome to proceed to the review and the exam. Best of luck on the exam. I am cheering for you.